All right, let's do a really quick review of the interest formulas. A reminder that we have simple interest, which is principal times rate times time, or we have our principal times 1 plus our rate over number of times compounded per year to the number of times compounded per year times time in years. Or there's continuously compounded interest with this principal times e to the rate times time power. Those are the two main interest formulas. We have compounded interest n times per year and continuously compounded interest. That is important for our question because we are going to determine how long it'll take $8,000 compounded monthly at 6% to double. Well, we need to write our equation. Our amount is going to equal our principal, which is 8,000, times 1 plus the rate, which is 6%, so 0.06, over number of times compounded per year. Well, if it's monthly, that's 12 times per year, to the 12 times t power, because we don't know how many years. But I do know I want it to double. So the amount in my account needs to be 16,000. And I can figure out 1 plus 0.06 over 12. That is 1.005. That just makes my life a little easier. Still to the 12t power. Well, to get a variable out of the exponent, I have to use a logarithm. So we're going to first isolate the exponent part by dividing by 8,000. So I get 2 equals 1.005 to the 12t power. Now we have to do a logarithm. The base of my logarithm should be the base of my exponent, so 1.005. Inside the logarithm is what it equals, so 2. And my logarithm should equal the exponent, which is 12t. To get my t fully alone, I'm going to be dividing by 12. And remember, to figure out log base 1.005 of 2, I need to use the change of base formula. So I can use log of or ln of 2 over log or ln, just make sure it matches, of 1.005. Then whatever I get there, I'm going to divide it by 12. And that'll tell me what t is. So I grab my calculator, log of 2 divided by log of 1.005 is 138.975. Divide that by 12. I get that t is about 11.581 years. There's my answer. Next up, a company spends X hundreds of dollars on an advertising campaign. The amount of money in sales, S of X, in thousands of dollars for the 4-month period after the advertising campaign can be modeled by S of X equals 5 plus 7 ln of X plus 1. If the sales total $19,100, how much was spent on advertising? Well, my sales is going to be 19,100, but that's in thousands. So really S of X needs to be 19.1 equals 5 plus 7 ln of X plus 1. Now we're going to solve for X. So I subtract my 5. I want to isolate the natural log. 14.1 equals 7 ln of X plus 1. Divide by 7. I get 2.014-ish equals ln of X plus 1. Save that decimal. You don't want to use the rounded one for our next calculations. Now to undo a logarithm, I need to rewrite it as an exponent. Remember, the base of this exponent, or the base of the logarithm, is e to the power of 2.014 equals what's inside of the exponent, or inside of the logarithm. So to get my final answer, I'll subtract the 1 over. So into my calculator, I need e to this power that I should still have in my calculator, minus 1. So to do that, look at that, I still have that number in my calculator here. I do second ln for my e, and then hit second negative to get ans, get out of the exponent, minus 1. So my answer is x equals 6.4 Well, 6.495 is in hundreds of dollars. So that actually becomes $649.50. So I'm going to go one more decimal place, which makes it a 4. $649.54 was spent on advertising. Next up, we have a hard-boiled egg that cooled from 98 degrees Celsius to 45 degrees Celsius after 4 minutes in a bowl of 16 degrees Celsius water. The temperature of the egg, T, in degrees Celsius after T minutes, is given by this equation here. How long will it take the egg to cool to 20 degrees Celsius? Well, I want my capital T for temperature to be 20 equals 16 plus 82e to the negative 0.260 t. I need to solve for t. First thing is isolate the exponent, so I'll subtract 16 from both sides. And then I'll divide by 82. And 4 divided by 82, I'm going to leave that as a fraction and make it 2 over 41. I'd at least simplify it, right? Equals e to the negative 0.260 t. Now to get a t out of the exponent, I need to use a logarithm. My logarithm needs to have the same base, so I need a natural logarithm because it has a base of e. Inside of that is what it equals, so 2 over 41. My logarithm equals the exponent, which is negative 0.260 t. Now to get t totally by itself, I'm going to divide by negative 0.260. And now it's a calculator problem. Type in natural log of 2 over 41, and then divide that by negative divide that by negative 0.26. We get that t is about 11.617. Now we need to figure out what that label is. Well, lowercase t is in minutes. It'll take 11.617 minutes for that egg to cool. All right, now we're just going to do some basic solving ones. If 3 to the x power equals 243, then I would rewrite this as an exponent. I'll do a log with a base of 3, because the base should match, of 243 equals x. And remember, to solve this, we need ln or log of the big number over ln or log of the base to do change of base formula. So ln of 243 divided by ln of 3. My value of x is 5. Well, I could have done that one without a change of base, but I forgot. All right, 8 to the x power equals 4. Well, I could do this one without an exponent, or without a logarithm, because 2 to the third power is 8, and 2 to the second power is 4. Power 3 to a power of x is a power of 3x. Now, if I can rewrite this as the same base with different powers, I can just set the powers equal and not even have to use an exponent, or a logarithm, I mean. My x is 2/3. There we go, no calculator needed. All right, 3 to the x minus 1 power equals 27. Again, I don't need a calculator for this one, because I can rewrite 27 as 3 to a power. I can write it as 3 cubed. Well, now that I have the same base, I can set my exponents equal and solve for x by adding 1. So x equals 4. All right, over here, I would still rewrite this as an exponent. The base of my exponent is 5. My exponent is 2. And it equals what's inside the log, which is 5x. Well, 5 squared is 25. And if 25 equals 5x, then I divide by 5, and x equals 5. Natural log of 2x minus 1 equals 0. Let's rewrite this one as an exponent. My base is e, my exponent is 0, and it equals 2x minus 1. Well, anything to the 0 power is always 1. And now I just have a simple algebra problem. I add 1 to both sides, getting 2 equals 2x. I divide both sides by 2, giving me x equals 1. Now let's just do a little simplifying. If I have a natural log of e to a power, well, a natural log and an e to a power cancel each other out, leaving me just the exponent. So my answer is just 2x minus 1. For the second one, well, natural log and e to a power cancel each other out, leaving me just the power. So I have negative 1 plus 2x, because that negative 1 is completely separate. And for negative 8 plus e to the ln of x squared, e to the power of a natural log cancels each other out. That negative 8 hangs out, but this part just becomes the inside of the natural log, which is x squared. All right, some more solving for us. 4e to the x power equals 91. To get the x alone, I need to divide by 4 first. So e to the power of x equals 91 over 4. To undo e to the x power, I need a logarithm. So the natural log of 91 over 4 will equal whatever x is. Type that into my calculator. I get that x is approximately 3.125. Remember, always go 3 decimal places. For the next one, we're going to get the e to the x alone. So we're going to add 14 to both sides, giving me 3e to the x power equals 25. And then I'm going to divide by 3, getting my e to the x power alone equals 25 over 3. Well, to undo an e to the x power, I need a natural log of what it equals. So 25 over 3 will give me the exponent. Now I use my calculator. Natural log of 25 over 3. X is approximately 2.120. All right, next up, we need to get our e to a power alone, so we need to divide both sides by 1,000. We get e to the negative 4x power, 75 over 1,000. Let's write it as a decimal. It's 0.075. Now, to get the variable out of the exponent, I need to use a natural log, because it's a log with a base of e, of 0.075 equals my exponent of negative 4x. And then we will also divide that by negative 4 to get my x alone. Now I turn to my calculator, natural log of 0.075, and then divide by negative 4. I get x is about 0.648. And 10 to the x power equals 570. Well, this time I'm going to use a log with a base of 10, which is just our common logarithm, so just log, of 570 equals just x. Type that in my calculator. X is approximately 2.756. And for a little bit more complicated of a problem, the natural log of x plus 1 squared equals 2. I would start this problem off by noticing that this power of 2 can be rewritten out front. And then I can divide both sides by 2, giving me the natural log of x plus 1 equals 1. Now to solve a natural log problem, I take my base to the power of 1 equals x plus 1. Then I subtract 1 to get x alone. My x value is going to be e minus 1, which according to my calculator tells me x is approximately 1.718. Now there is another way you could have done this. You could have gone straight to e to the second power equals x plus 1 squared. Well, then you'd have to square root both sides. And you're going to get e equals x plus 1. And look at that, we're going to subtract 1 and get e minus 1 equals x. All depends which way you see the problem. And now for this beautiful problem. In order to get rid of logarithms when I have multiple logarithms, I need to condense them. So I see that I have subtraction here, and when I'm subtracting two logarithms with the same base, they can combine to be division. So the log keeps the same base of 10. The first thing is the numerator. The second thing is the denominator. Equals log base 10. I didn't change the right-hand side, so I'll keep it. Now if I have a log equals a log, and they have the same base, I can just drop the logs and set the insides equal. So x plus 4 over x equals x plus 2. Now I'm going to solve this. I'm going to multiply an x by both sides. I get x plus 4 equals x squared plus 2x. And then I have a quadratic going on, so I need to get it equal to 0. So I'll subtract an x from both sides and a 4 from both sides, giving me 0 equals x squared plus x minus 4. Well, that's not pretty. That doesn't factor. So that means quadratic formula. -1 plus or minus the square root of 1 squared minus 4 times 1 times -4 all over 2 times 1. And now if you're good enough with your calculator, you can just type that in. Or I can actually simplify it down and get -1 plus or minus the square root of 17 over 2. But let's check. Because -1 plus the square root of 17 over 2 is about 1.561. Okay. Looking back at my original problem, does that make any negatives inside my logarithms? No, that answer's fine. If I change that instead and check the minus, I get a negative. Log base 10 of -2.56 does not exist. You cannot put a negative number inside of a logarithm. So that one doesn't actually work. So our answer has to actually be -1 plus the square root of 17 over 2, because negative numbers are not allowed inside our logarithms.